Our general mindset in the UK is that we will make, do and mend. That is something that we shouldn't do. We should embrace our technologies. We're worldwide renowned for being research and development leaders. And that's something that we should continue to build on.
Welcome to this week's MTD podcast. In this podcast, we will be discussing the evolution of metrology, the new innovations that are now available, and why it's an absolute necessity for all engineers and manufacturers to embrace them. I'm Giovanni Albanese, hosting today's show, a passionate engineer and a very proud member of the MTD team. It's an absolute pleasure to be joined by two special guests. Firstly, David Shute, the National Technical Manager at Zeiss UK. Welcome, David.
Good morning, everybody.
Also, we are joined and have the pleasure to be joined by Al Kropp, Business Development Manager and Regional Sales at Zeiss UK. Welcome to this week's podcast, guys.
Morning, Gio.
How are you been? All right?
Very well, thank you. Yes, pleased to be here on this sunny day.
Well, let's start with finding out a little bit about yourselves. Now, you work for a large organisation, Zeiss. Now, David, what's your background?
My background is in engineering. I started a technical apprenticeship back in the mid-80s, a long time ago now. I know I don't look my age. Thank you very much. My apprenticeship was with Jaguar Cars, based out of Coventry. It was a 5-year apprenticeship, and from that point on, I was an engineer for a period of time, leaving in 1993 to contract and ping around doing different things. I spent a bit of time working with subcontractors for the MOD, and then from there I moved on to, dare I say it, Mitutoyo. And then from my days at Mitutoyo, I then moved on to Carl Zeiss, and I've been here ever since.
And what do you actually do now at Carl Zeiss? I know that your role's changed slightly.
I'm the National Technical Manager. The role has a number of different facets to it. It's more of a strategic role, looking at different areas of application, looking at how we can take the products that we now have and implement them into the new areas of application, looking at NEV, aerospace, medical sector, and so on and so forth.
And finally, David, why did you get into engineering in the first place?
I was educated in Coventry, and back in the 80s, as I'm sure some of the listeners will know, Coventry was the powerhouse for manufacturing in the Midlands and also across the UK. Having Jaguar Cars, Peugeot Talbot, TR Matrix, a number of other companies there, Austin Rover as well were there at the time. So it was a natural progression to get into something that I'd been brought up around and I had a passion for.
Brilliant, David. Now, Al, I know that you've got a slightly different background. Can you tell the listeners a bit about your background and why you got into engineering or how you got into engineering?
Yes, absolutely. Well, certainly like many people at Zeiss, we all come in from different avenues with different backgrounds and different skill sets. I'm actually a mining engineer, a geologist by background. So my training is really in that industry, which stems from my interest in rocks and minerals, how they come together, how you take them apart efficiently and in an environmentally friendly way. So I spent 10 years or so working over in Australia in a consulting role and developing techniques and technologies for use in the mining industry. And a lot of that actually was in partnership with Zeiss. So we used to buy instruments from Zeiss and then convert them for use into the mining industry. And obviously, when I moved back to the UK, the mining industry here is not so huge. But with the contacts I already had within Zeiss, it was a natural fit to join Zeiss, continue building some of those products as a product manager, and then more recently moving into a account management and sort of customer-focused role here in the UK, which allows a sort of combination, I suppose, of those technical background, engineering background, with being out there meeting very interesting people doing very interesting things.
I mean, going into this kind of industry, I'm sure you're seeing a lot of different processes, different technologies. How are you finding the transition? Because it's quite a big transition, isn't it?
Well, that's certainly one of the joys of doing this job. As I say, interesting people doing interesting things. You know, you get to learn a little bit about lots and lots of things. Certainly within Zeiss, we have no shortage of people with technical backgrounds. And I see really my role is trying to string all of those things together. So spending time with customers to understand what their challenges are, what they're working on, where the pain points are, and then really trying to link that in with the hundreds, thousands of people that we've got within Zeiss that might have the relevant technical knowledge and experience to come together, I suppose, as a team to work with those customers to help move things forward and solve some of those challenges for them.
Zeiss is an organisation, you mentioned hundreds of thousands of people. It's a huge organisation globally. Now, David, can you tell me a little bit about Zeiss?
Zeiss is a foundation. We're privately owned, for want of a better word. We don't have any shareholders. So all of the work that we do and all of the dividends that come from that get pumped back into the company. The company's been around for the past 173 years now, I think it is.
Wow.
So yeah, it's started in Carl Zeiss Jena with Carl Zeiss, making microscopes and so on and so forth. He was then joined by a guy called Ernst Abbe, who developed the Ernst Abbe comparator principle, which all CMMs are built around. And then Otto Schott came on board, who was almost like a chemist, and he dealt with the metallurgy that was involved with making glass and so on and so forth. And they came together and began to build Zeiss into what it is today, situated around 40 different countries with over 30,000 people working, and a multi-billion euro business, I should say.
Wow, what a fantastic story that is. And over that time, I'm sure there's been so much innovation and technology and evolution. And that's really the main reason of this podcast, not just for people that are inspecting components, but manufacturers and engineers of any component. This podcast is relevant. So can you kind of give me your opinions to why evolution and innovation is so essential? I'll start with you, please.
Now, certainly industry is moving faster and faster. I mean, I think we've all seen that over the years. The need for greater accuracy for different types of parts, different types of materials are growing. If we look back not that very many years, that the bulk of what we used to see in engineering and metrology here in the UK was really around the combustion engine, powertrains. But that has changed dramatically over the last 5 or 6 years with the advent, of course, of NEV, new energy vehicles, battery technology, additive manufacturing, medical devices, drug delivery devices. There's lots of these emerging areas that are all making highly accurate parts and components and need new ways of measuring things. So particularly with things like additive manufacturing and batteries, it's no longer good enough to be looking at just the surface. You need to be looking inside things, which is where the CT and X-ray non-destructive technologies have really been on the rise over the last few years.
I mean, the technology there on more accurate parts, it's an absolute requirement. I mean, we had Cogsdill in recently for a podcast, and he used an analogy from Henry Ford. He said that when they were working with Henry Ford in America, because they had a relationship, if they'd have asked the people what they wanted at the time, they'd have said a faster horse. So, I mean, there is definitely a massive reason to invest in the latest innovations and technologies. Now, David, in our industry, when manufacturing a component, the components obviously, as Al says, need to be more accurate now, better surface finishes, they're more complex, 3D milling. So obviously the inspection needs to change. The way in which you check that component needs to change, not only to measure it more accurately, but in the time in which you check that component so you don't get a backlog in production. Is that correct?
It is correct, yes. Using the example that Al gave, additive manufacturing, we have a number of our strategic partners now who are working in that arena. With additive manufacturing, the designers get the freedom to do whatever they want to do. So traditional metrology techniques using the standard tactile type of setup really isn't cutting the mustard anymore. You have to have more of a non-contact feel for it. Using CT and optical systems, be it line scanners or chromatic white light source coming from the dot scan. And because additive manufacturing is still in its infancy, I know there's companies out there that are running with it on a daily basis, but it is still predominantly in its infancy. And our partners have a good understanding as to what goes on within that manufacturing process, but they don't understand it to the point whereby they do sample inspection. So most of the time they're inspecting every part, which then means we have to have an extremely efficient system that enables us to scan these parts in such a way that we can actually keep up with the real manufacturing process, yes? Whereas previously, with the traditional metrology techniques, you'd have a sample inspection rate of every 200 or 300 parts. So time wasn't as critical as it is today. So yes, we're having to change the way we actually evaluate the components, looking outwardly and inwardly. We're also having to be far more efficient from an automation and also from an actual inspection perspective with regards to how we get the results as quickly as possible.
I think that really hits the nail on the head. You know, you've explained that so well. Now, can you kind of abbreviate really on the products really? You mentioned CT scanners. For people out there that are unaware of CT scanners or your optical solutions and scanning as well, can you give me examples, David, of how these would be used or for what kind of applications? You mentioned 3D printing and additive manufacturing, but what about, still, the standard, the majority of products that are still made out there?
When you say a majority of the products, you're talking about with additive manufacturing and using the traditional manufacturing methods?
No, I'm talking about the machined components that make up the majority of components that are manufactured on a CNC machine, or castings, for example. Are there products such as that CT scanners are used on, that optical measurements are used on? I mean, we've got David Torr coming in later on today that we'll be speaking about. I went to visit him last year, actually, and he kind of bought one of your O scans, I believe, or an optical scanner to measure a part that couldn't be measured with a tactile solution. So can you give me just some examples about what your products do and the solutions that they provide?
Okay, well, we have our traditional metrology equipment, which are our CMMs, ranging from, you mentioned the O-Inspect, which is our multi-sensor system. That gives you the ability to either measure something from a tactile standpoint, or using the camera system, or using a chromatic white light source as a dot scan. We have our standard bridge machine technology, which again has the ability not only to measure from a tactile perspective, but also we have non-contact capabilities with the dot scan, with the line scan, with something called a V-scan sensor as well. So contained within the same format, you've got all of those possibilities that you can flick between mid-CNC. So that's where one of the efficiency gains has come in, whereas previously you'd have to have your traditional measurement or traditional tactile measurement done on the CMM, then you'd have to take it somewhere else to have another part of the measurement actually performed, whereas you can actually do it now all on the same platform, including surface topography as well with our higher end machines with the Rotos sensor.
I mean, this is new technology, and I mean, that really makes the products that you're supplying more modular. That's correct, isn't it? It's safe to say, Al. Now, Al, can you just tell me about some of the new products that you have at Zeiss?
Yeah, absolutely. Well, certainly Dave has obviously spoken about the bridge CMMs and perhaps the more traditional sort of metrology side of things, which continues to develop. But as we mentioned earlier on, one of the biggest areas that we see the changing technology and innovation coming in is within the non-destructive space in 3D. So CT scanners in various forms. So think of a CT scanner as being the sort of thing you see in a hospital, where you put the patient in and it scans around the body and gives you a 3D representation of what's going on inside your body. It's the same principle. The only difference is that we rotate the part rather than the actual scanner itself. But that then applies into a whole range of different areas.
Give me an example, Al.
Well, for example, very rapid scans with some systems that we recently acquired actually would be looking at things like casting defects in alloy wheels, for example. A second or two per scan, it's a quick snap, it gives you an idea of whether there's any cracks or defects within the castings. So used directly for quality control. We've got other systems, CT systems, that are used in the medical device industry, looking at plastics. So where you've got multiple plastic components that click together and you want to look at how well they actually connect. For example, the flow of fluid is through there and how robust a device is. Has it actually come together as you'd expected it to deliver a drug efficiently and appropriately, not too much, not too little? Then really the only way of doing that is to use something like a CT scanner to look inside to check that. And then on the higher end, we've got CT scanners that we've actually developed that integrate a microscope. And what that does is opens up a whole new world of resolution that you can't reach with any other technology. So the detail that you can see within some parts, even down to a grain structure and a grain sizing technology, is amazing. And that's opening up a whole new series of areas as well.
That's a massive marketplaces that can be opened up. And you offer a bureau service with the CT scanners as well. Is that correct, David?
Yes, we do. We offer a bureau service out of our facility in Rugby. And if we aren't able to cope with what the customer requires, then we can ship that out to our headquarters in Germany for the larger parts.
Now, I know that you deal with some of the major OEMs around the world, car manufacturers, the aerospace industry, medical industry, but I want to just touch upon the smaller manufacturers, the small to medium-sized engineering companies that may invest a lot of money into manufacturing the parts faster, but may overlook inspection, or when I say overlook inspection, may overlook the reasons why they need to invest in the latest metrology equipment. Can you give me an argument to say, look, it's absolutely imperative that you also invest in the latest metrology too?
CMMs or metrology equipment historically has always been seen as something that doesn't actually produce something. Yes, it's always been seen as an overhead, as opposed to the way we look at it. It's the gatekeeper to anything leaving the manufacturing facility and going off to the customer. So it's imperative that you have metrology equipment in-house, be it Zeiss or another type of equipment, to monitor the process. You can't just rely on the process to be the all-seeing eye with regards to the quality of product that you produce. So
It's, in my opinion, it's absolutely imperative and it should be looked upon as the complete process. So, for example, if you're manufacturing a part, the metrology should be looked at part of that process, not a separate process. Same as automation. And I think that everything is interlinked. And also with the fact that now digitalization is coming into play, and you also got a solution for that we're going to touch upon shortly. I think that it's imperative that people are educated into this if they're looking to achieve the very, very best results, because it's pointless getting the best manufacturing process implemented into your facility, but then not having the best metrology and inspection process, because obviously you're not getting the best complete process. Does that make sense? I mean, you're looking at yourselves as solution providers now. Is that correct? Is this a new philosophy from Zeiss?
Over the last few years, that's been one of the biggest shifts that I've seen in the way that Zeiss works and approaches the industry. It's moving away from just being a provider of really great quality machines and looking at the much wider picture on, as you say, Gio, all the other things that need to come together to make that successful. And to go back to what I think you were just talking about there, the fundamental training and the understanding is absolutely key. At the end of the day, you can buy the best instrument in the world, but if it's not being used appropriately and to its greatest ability, then of course that's wasted money, wasted time, and is not really adding any value. So certainly what we've done is expand out the training academy that we have here at Zeiss. Of course, we still provide the training on the actual instruments and the software, Calypso software and so on, that you need to actually push the machine around. But it's incorporating all the other things that you need to do. So, for example, later on last year, we got accreditation to provide ORCOM training. ORCOM is globally recognized as the largest provider of metrology qualifications in the world, or certifications in the world. We now are licensed to actually provide that course contents here in the UK as well. So what that does is it gives us a chance to train generic metrology skills, engineering skills, how to interpret drawings, how to build programs, and the fundamental principles that you're going to use to approach getting the best out of whatever systems that they are that you use, whether they're from Zeiss or from anybody else. So that fundamental understanding and training is obviously going to enhance not only what you do as an individual, but if that goes across the company, then it really means that you're all singing off the same hymn sheet, you're talking the same language, and that anybody can effectively approach the same part, get some measurements, and have comparable results, rather than having different approaches. So it's really about homogenizing and evening off the language that people use and talk about.
Education, then, it's safe to say that education is key.
It's at
absolutely
the heart of it all.
key. Yeah. So, I mean, we bring education into the scenario then, and in regards to your training that you offer and also the software that you offer that kind of goes hand in hand, that kind of simplifies the way in which data is collected and how you can use that data. I know, David, we've done a video last year as well on PyWeb, and now you also have smart services that you're offering. Can you give me a little bit of an insight into how the software can also help your customers and how it benefits them ultimately?
Al brushed upon outcome. Outcome, just to elaborate a little bit, is the foundation to everything. It gives our customer base the ability to understand metrology principles from the ground up. That's the outcome level 1. Outcome level 2 then goes into more in-depth type 3-dimensional type measurement, with it being a recognized standard. From that point on, we then offer our Calypso training. Yes, Calypso is the base software that pushes our machines around. The results coming from the Calypso system then get fed into our PyWeb system. PyWeb system is a web-based application. It's different to other things on the marketplace, whereby it's a visualization tool. It's a reporting package that also has the capability to evaluate statistical analysis as well. But the beauty of it is it's very visual, it's very easy to use, and the data coming from the measurements are encompassed within the same areas. So you could evaluate your day-to-day stuff, and then if you do perceive there being some form of manufacturing problem, then you can drill down into the SPZ data straight away without having to go to a different platform and evaluate it accordingly. Smart services, again, that's something that we're rolling out, and that will enable us to remotely log into systems moving forward without in most cases, there being a need for a service engineer to go and visit site. In a lot of cases, we'll be able to fix the system remotely and get the system back up and running as quickly as possible.
Well, if you're collecting data, but you don't use that data correctly, it's absolutely worthless, isn't it? But with the software that you are incorporating and integrating into your hardware and the machine tools as well, it's ultimately kind of increasing productivity and efficiencies within manufacturing facilities. Is that correct?
That's correct, yes. We've had what we call the closed loop system for some time, whereby we can send information back to the machine tools, enabling them to make real-time adjustments, alleviating the need for operators to actually go and report the result or evaluate the result, I should say, then go back to the machine tool afterwards. So we have that capability.
So in layman's terms, I know we were mentioning Apple before this podcast started, and some of us like Apple and some of us don't, but effectively it's like different products talking to each other. It's a clever system that's taking some of the human error out of the equation.
I wouldn't say human error being taken out of the equation. It's enabling our customer base to evaluate their process real time. Yes. In a lot of cases, if you're too reactive, then it can portray a false image as to the fact that your process is potentially out of control. So using machine learning algorithms now within our PyWeb software, what we're able to do is create new mathematical maps in and around the customer requirements. The customer would give us a specification as to how they wanted this machine learning algorithm to work and what parameters it would be working with. And we would then feed that into the system, and then those parameters would then be used to send information back to the manufacturing process real time and keep control of the manufacturing process. It just gives the customer that additional reassurance that things are working in the way that they should. And if, as and when something was to drift, then using PyWeb as an example, with it being a web-based application with apps that feed into mobile phones and any other mobile device that you have, you could actually evaluate the data real time. So not that you'd want to, but theoretically you could be sitting on the beach and you could have up to the second details as to what your manufacturing process was doing back in the UK.
So with all these innovations in place, all this new software in place, I mean, we've not even touched on artificial intelligence. And then you bring in the outcome courses and training. Effectively, are you trying to create standardization, a stable process, something that everyone can adhere to get the very best results?
As an organization, our core values have always been around making sure that our customer base and our partners produce quality parts and have the reassurance that our systems that we supply into them make sure that that most definitely happens. We are focusing more on being an overall solutions provider, whereby we just want to sit down with our customers and non-customers as well, listen to what their pain points are, in the hope that we can advise them accordingly on how they can better approach these particular pinch points and pain points moving forward.
That's brilliant, David. Now, Al, you mentioned outcome and education. Let's move on to education. There's a big misconception in the UK, let's be honest, about engineering and that it's still a dirty industry and there's a big skills gap. People in Italy and Germany get perceived as doctors and dentists, but in the UK, being an engineer, you haven't got the same kind of rapport. Why should, in your opinions, should students get into engineering and manufacturing?
It's interesting that you say that that's still the perception. I think that's changing very rapidly. The engineering world is really at the cutting edge of everything that we see around us. So to get access to the very latest and greatest of innovations and ideas that are out there, then really, I mean, a lot of that's driven by the engineering space. You know, you look at what's happening in the aviation industry, for example, certainly, you know, so some of the cutting edge stuff that's happening with the MOD. You could be out there working on fighter jets, for example. The rise of new electric vehicles, new energy vehicles is really driving some fantastic innovations and ideas in that sort of space. You know, you could end up working for a Formula One team. You know, there's so much out there that's moving at a very, very fast pace, right at the cutting edge, that requires people who can move and think and work in that sort of environment.
And I totally agree with you. I think that we are at the very forefront of technology, but why is there such a perception or a misconception, or why aren't we getting the people into the industry that we need to be getting into it? I mean, a lot of people want to bypass kind of making things and just want to sit down on a computer. You know, there's a big skills gap. Why is that?
There's a number of ways you can look at this, isn't there? There's the macroeconomics going all the way back to in the UK, I'm talking now, going all the way back to the mid-80s, where manufacturing as we knew it gradually began to drop off. There was the introduction of globalization that sped up exponentially, whereby a lot of the manufacturing in the UK disappeared. Then there was a lull for a period of time whereby apprenticeships weren't really the trendy thing to do. We had a services industry that was on the increase and so on and so forth. Well, I could go on and on. And governments since 2009, 2010 have realized that we need to add value. And how do we add value? And we make something, we take the raw materials, we make something, we add value to it, then we export it and we sell it to other parts of the world. But I think that lull where we had the lack of apprenticeships, it's still there. Catapult centres and so on and so forth, they're doing their best in order to incentivise people to come back into the industry. Going over to the point that Al just made, dare I say it, engineering and manufacturing is becoming a lot more sexy now than it used to. We had almost like this technology lull for a period of time, didn't we, with the internal combustion engine and so on. And is deemed as being, as you said, a dirty place to be. But that, in moving forward, most definitely isn't going to be the case. With the introduction of NEV and so on and so forth, the dynamics of how things work and what's being manufactured is completely changing to the point now where it's a very techie environment, as opposed to previously being more of an antiquated in third or second or third industrial revolution type place to be.
Yeah, I totally agree with you. I mean, I've been in the industry for about 26 years and I love it. I think that you can get any job within the industry, but I have still got concerns that it's not promoted well enough to the younger generation from a ground roots level. You know, I go to colleges and universities and there's a lack of students that want to get into engineering because they don't know how good it is now. What can we do more to showcase our industry? We still need to raise awareness because all three of us know it is at the forefront of technology. It's a fantastic place to work. Some of the jobs within the industry are the best that you can get.
You're absolutely right. And I think it's incumbent on everybody working in this space to be out there promoting it to the younger generations. And primary schools, I think, are a classic target of that. You know, picking up on children at that age who are interested in building things, for example. If you enjoy Lego or you enjoy Meccano or whatever, then that actually is a skill that will take you on. Or if you like computers or you like mathematics, it's making that bridge between the stuff that you're interested in at that age and what could you do as a job. And that's something that actually we do work hard at Zeiss as well. I'm working on the STEM subjects out there with school children. I know next week, for example, we have a team at the NEC in Birmingham at the Big Bang Fair, which is the opportunity for 7,000 or 8,000 primary age school children to come through and see what companies like Zeiss do with technology. So we have a team there working with a number of our different products they can just have a go at looking at things, measuring things, seeing things. There'll be lots of other engineering companies there that then take on the tools that we supply and then use them to go off and build things. So I think it's painting that picture for the children at that age to say, cool, I love maths, I love physics, I love building stuff. I could go and make an aeroplane or whatever the link is.
Yeah, absolutely brilliant. No, that's fantastic. I really do hope that more people do get into this industry. Now, I just want to wrap this up really. You know, thanks very much for your time, gents. Can you give us an insight into what is the future of Zeiss then? Its innovations are kind of moving forward at such a rate, we can't keep up. What's next?
What's next?
Well, I think that's
Is that a secret?
Well, there's always secrets, absolutely, of course. But I think it's continuing to expand on the other things that come around. I mean, of course, we'll continue to build great products and measuring systems. But I think it's all the other things that come around making that successful, increasing productivity, making better use of big data, and generally smoothing out the workflows and making it easier for companies. I mean, you mentioned small engineering companies earlier on. Making it easier for them to get access to technology that's quicker, easier to use, more cost effective, as well as, of course, the high-end stuff, which is the big engineering companies who need tools like the PyWeb system to look at data on big trends, mega trends across all their factories around the world and so on.
That's just reminded me actually, Al, before we go, this podcast was based around evolution and innovation. And it's not just about the products, it's actually the way in which you're selling the products too. You did mention prior to this podcast that you are, as an organisation, selling the products differently. Can you kind of tell me what tell the audience what you were telling me, please.
Yeah, so certainly going back to what we've been talking a lot about today, it's the pace that technology is moving. Is we've found that a lot of companies are moving away from the principle of I can buy a CMM and I can use this for the next 15 or 20 years and that will be sufficient for my needs. We're finding that the pace of development and their requirements are moving much faster than that nowadays. So one of the things that we've done is look at that and work out how we can provide more innovative ways of giving customers access to systems and machines and solutions. So one of the things that we're seeing more of is the requirement for leasing. So as I say, moving away from buying a machine for 15 or 20 years and then finding that for the latter 10 years of that it's obsolete, but you can't get the justification to replace it, moving to something like a 5-year or a 7-year lease, just like you would do with your car, gives you then the chance at the end of that to reevaluate technology, reevaluate the parts that you're making and your requirements within your production and your workflow and say, is this still fit for purpose? In which case we can carry on with it. Or do we need something else? In which case we need to look at leasing a different type of product or a different type of technology that meets our current needs. It's very hard to look into the future and say, what are we going to be making in 5 years or 10 years or 15 years time?
Really
And
good
not
point.
many companies can answer that question.
No, absolutely. Really good point. Staying on top of the latest innovations. Now, David, just want you to wrap up really. Any last thoughts? And why should people invest in the latest technology? What will happen if they don't?
Things are moving extremely quickly. We talked about globalization. We talked about, we've been talking about Industry 4.0 for such a long time. And everybody being connected and the general mindset of the up and coming generation being completely different to what ours was years ago. And the rest of the world picking up and running with this technology and adopting it and embracing it. And what we need to do in the UK is most definitely continue with what we're doing. But in my opinion, we need to ramp things up a little bit. Our general mindset currently in the UK is that we will make, do and mend. And that is something that we shouldn't do. We should embrace our technologies. We're worldwide renowned for being R&D, research and development leaders. And that's something that we should continue to build on, most definitely. If we don't, then there is a possibility that we could be left behind. What we want to do is not just be R&D leaders just in the UK, but we want to be manufacturing leaders again. In order to do that, we have to be competitive. We have to increase on our productivity. And the only way we're going to be competitive, increasing productivity, is investing in the latest technologies.
David, that's absolutely brilliant. Thank you very much. David, thanks for your time. Al, thank you very much for your time. It's been an absolute pleasure. It's been an informative podcast. If any of the audience have enjoyed this podcast, please subscribe, comment, and let us know what you think. And if you've got any questions for Zeiss, please get in touch with them. If you're looking to improve efficiencies and productivity within your facility through Metrology, get in touch with Zeiss. Thank you very much.
Thank you.
Thanks for listening to the MTD podcast. If you found value in this episode, please subscribe and leave a rating and review. Find more episodes on mtdcnc.com.